This video goes along with Eureka Math grade 7-8 or level 7-8, module 3, lesson 13, okay, the angle sum of a triangle. Okay. In this first 6 problems, it wants us to use some patty paper to trace these angles to make triangles and see if we can actually form a triangle based off of the angles given. However, since I don't have that material, we're going to talk about how we know if angles make a triangle. Okay, so starting with, go ahead and flip to questions 1 through 6 here on the next page. Okay. A triangle has 180 degrees. Okay, so if we add up the angle measurements and we don't get 180 degrees, we cannot make a triangle with that. In this case, I have 30 plus 40 plus 100, which makes 170 degrees. Not going to be able to make a triangle. For number 2, I have 50, 60, and 90 degrees, which adds up to 200. Again, not a triangle. 40, 60, and 80 add up to 180 degrees, so this is in fact a triangle. 30 plus 60 plus 90 adds up to 180. Again, a triangle. 40 plus 50 plus 100 is 190, not a triangle. And we have 30 and 50 and 100, which add up to 180, which makes a triangle. Looking at question 7, okay, we're going to fill in the blanks to complete this equation. So measure of angle 4 plus measure of angle 5 equals blank. Well, angle 4 and angle 5, okay, they're not alternate interior angles, so we can't say they equal each other. Okay, however, I could say that angle 5 is a corresponding angle with angle 1. And angle 1 and angle 4 are supplementary. And supplementary angles add up to 180 degrees. So if these two add up to 180, and angle 5 is equivalent to angle 1, we could say that angle 4 and angle 5 also add up to 180 degrees. Also, again, angle 4 and angle 5 are what we call consecutive interior angles. And consecutive interior angles will add up to 180 degrees. On question 8, we're going to again fill in the blank here. Okay, measure of angle 5, 9, and 10 equal what? Well, looking through here, I've got to find some kind of way to relate 5, 9, and 10. There's a few different ways that we could talk about this. For instance, if I notice that I have 2 parallel lines, and I do have 2 transversals here. Okay? I have a transversal that is intersecting this way and one that is intersecting this way. Okay? So I could look at line L intersecting here, and I could say that angle 5 is an alternate interior angle with this angle right here. And since I have these 3 angles that form a straight line, we have angles on a line which add up to 180 degrees. We could also say that angle 10 and angle 11, because of this intersecting transversal right here, 10 and 11 are congruent because they are also alternate interior angles. So we could replace 10 for 11 and have 5, 9, and 10 make up the triangle. And we know that the measure of the angles of a triangle is 180 degrees. So what do we know about the measures of angle 10 and 11? Well, we just said they're alternate interior angles. So that means the angle measures are congruent. Because angle 10 and angle 11 are alternate interior angles. Okay. Because of that, we could say that angle 10 is part of a triangle, which adds up to 180 degrees. Question 6. So we just talked about that. 5, 9, and 11. 5, 9, and 11 make up a triangle, and a triangle is 180 degrees. Okay. We would say the three angles form a triangle, and the angles of a triangle add up to 180 degrees. So for D, if measure of angle 5 is 51, measure of angle 9 is 75, what is the measure of angle 11? Well, the measure of angle 11 is equal to 180 degrees minus the measure of angle 5 and the measure of angle 9. Okay, so I'm going to add these two together. So 180 minus 51 plus 75, which is 126. And when I subtract there, I get the measure of angle 11 to be 54 degrees. If you're missing that third angle, okay, subtract the other two from 180 and then use that information to solve for the other part. Sometimes it might be an equation, sometimes it might be just a single number. Okay. Add the other two angles, subtract from 180, and use that to determine the measure of your angle, or if you're solving for x. Number 9 is not necessarily a question, just some statements to give us some information here. Okay, it says, if corresponding angles created by lines L and M are cut by transversal T are congruent, then lines L and M are parallel. If lines L and M are not parallel, then corresponding angles created by lines L and M cut by transversal T are not congruent. What this is saying is, if you have your corresponding angles that are congruent. So if I draw a little diagram here, okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if my corresponding angles, so 1 and 5, 2 and 6, 3 and 7, 4 and 8, if all of those sets of angles are congruent, then we have parallel lines. If they're not congruent, okay, then we would not have parallel lines. That is what these two statements are saying. Because what we're going to do is we're going to solve and try to find, okay, with questions 11 and 12, determine if the lines are parallel. Okay, so on number 11, we're looking to see if C and D are parallel. Well, in order to do that, I have to determine what the measures of all the angles are that I can find. For instance, I know that because of vertical angles, I have 100 degrees. I know that these two angles are supplementary because they form a straight line. So I'm going to take 180 minus 100, and that gives me 80. So I have this angle measurement to be 80 degrees. Okay. Well, if this is 80 degrees, by the way of vertical angles, so is that angle measurement. So I've determined all the angles for this top set. I need to do the same for the bottom. Well, again, I know this is 80 degrees because of vertical angles. And I know that these two angles together make a straight line, which gives me 180. So 180 minus 80 is 100 degrees. And if this is 100 degrees, because the vertical angle, so is that angle. Now that I have all the angles that I can find, I'm going to determine if these are parallel or not by looking at my corresponding pairs. So 1 and 5 are congruent, 2 and 6 are congruent, 3 and 7, yes, 4 and 8, yes. Okay, so corresponding angles are all congruent. So this would be parallel lines. Okay, so we would say lines C and D are parallel because the corresponding angles are congruent. Okay. Your matching angles, okay, they are congruent. You cannot just assume, okay? We're not looking to see what the angle measurements are. We have to find those. But we're saying, hey, are these lines parallel? Okay. You cannot just go through and say, oh, 100, 100, 100, 100. Yes, I know those are the corresponding angles, but we have to actually determine if they are congruent or not. Okay. For instance, if I'm looking at this right here, I know that because of vertical angles, this is 135 and this is 45. However, I have no information on what any of these are. So we can't say whether they are or not. We would simply say undetermined. Okay, it's undetermined because we do not know the rest of the angles here. We can't compare. We can't see if they're corresponding. Okay? Don't just write 45, 135, 135, 45 and say, oh yeah, they're parallel. There's nothing that tells us what these measurements are. Okay? What you might see, I'm going to come up here and use this space right here. Okay? Okay? Let's just say that this is 110, and we said this was 62. Okay. Well, how would I know if these lines are parallel or not? Well, I need to finish filling in all of the lines, or all the angles. Again, vertical angles makes that 110. These are supplementary because they make a straight line. So 180 minus 110 is 70. Well, I can already tell right here that my corresponding angles right there are not the same. So without having to do any other work, because even if I did, I would take 180 minus 62, okay, and that would give me 118. Well, these would be 62 and 118. If you look, my corresponding angles are not congruent. They don't have the same measurements. So this would be not parallel. And we would just say corresponding angles are not congruent. Okay. So we're looking at, do we have corresponding angles congruent? That makes them parallel. If they're not congruent, not parallel. And then we're looking at using angle relationships, triangle angle measurements to find missing sides of triangles.